This is the forward, that's a pointer, this is forward, backwards.
Good morning. Today I would like to talk about my project and ultimate goal of this research, that I'm going to looking at the application of TLR ligands as an alternative approach in chickens as antiviral agents to reduce the shedding of avian influenza virus. As you may know, influenza is historically an ancient disease that caused economic losses and declines in production, especially in in poultry industry. And in the case of influenza virus, we know that in 2004 there was a outbreaks of influenza in BC that caused economic losses around $380 million. In the case of avian influenza virus, biosecurity is the most important prophylactic approach. However, vaccination is customary in some regions of the world, but vaccination has some disadvantages. As a result, there is a need for alternative approaches. One important thing is the influenza virus, because of vaccines, needs several days to elicit protective immunity. So this delay in response is not ideal in outbreak situation. There is a need to apply alternative approaches to modulate host innate responses to induce these responses to reduce the replication of the virus in hosts and reduce the spread of virus. One of them could be applying TLR ligands in chickens, that they are safe, cheap, applicable, and potent. But you may ask what TLR are. TLR or toll-like receptors are receptors that they are present on the surface of cells. On the surface of cells, or some of them are inside the cells. And now there are some synthetic or natural component of ligands for these TLR. In this project, we want to develop one alternative approach to enhance quick host immune responses against avian influenza virus, and look at the potency of these ligands in chickens and how we can reduce the shedding of the virus. And in addition, we want to characterize the induced immune responses in trachea. For that reason, and to determine the potency of these ligands and their ability to induce antiviral responses and underlying mechanism, we employ in vitro and in ovo experiments, and we could show that TLR ligands are able to reduce the AIV replication in chicken macrophages or even in embryonated eggs. And because of these promising results with this experiment, we applied these ligands in chickens, and finally we could show that the treatment of chickens with these ligands using a specific dose and route of administration, because we tried different types of ligands, different doses and route of administration, we showed we could significantly reduce the shedding of avian influenza virus in chickens. And after that, because we wanted to determine the relevance of innate responses in the respiratory system against avian influenza virus, we set up some assays such as organ culture and culture of primary epithelial cells to characterize and profile antiviral responses in trachea, and we could find and confirm that these ligands are able to induce some antiviral responses in trachea. That is really important for responses against avian influenza virus. And at the end, I would like to thank my advisor, Dr. Sharif, and all Dr. Sharif's members, and thank you for attention to my presentation. I'll be happy to answer your questions.